A sample contains 16,000 atoms of hydrogen 3,1. Calculate the number of atoms present in the sample after 12 years. So we know that we have a half-life of for this isotope of 12 years, and now we are being given a period of 48 years. So the number of half-lives in 48 years are going to be 4, which means that number of atoms could be found if we divide the initial number by 2 raised to n or 2 raised to 4, which gives us an answer of 1000 atoms. Welcome to this tutorial. I'm solving question number 11 of paper 2-2 of May-June exam series of 2016. This paper is related to GCSE O-level physics. Question says figure 11.1 represents a nuclear fusion reaction. In this reaction, we can see that hydrogen 3,1, which is the tritium isotope of hydrogen, is combining with hydrogen deuterium, which is another isotope of hydrogen, and they produce two particles. One of the particle is A and the other particle is B. Now, the shape and the shading used, it gives us a clear idea that in hydrogen 3,1 we know that one proton is present. So proton is being represented by this black circle, and two neutrons should be there, which is represented by these gray circles. So the gray circle is representing a neutron, and the dark circle is representing a proton. The question says at very high temperatures, nuclei of two isotopes of hydrogen 2,1 and hydrogen 3,1 fuse together. Energy is produced and the two new particles are formed, particle A and particle B. Explain what is meant by isotopes of hydrogen. It means that they are atoms of hydrogen with same number of protons but different number of neutrons. That is why they are called the isotopes of hydrogen. Using figure 11.1, state the number of neutrons in a nucleus of the isotope of H31. So number of neutrons are 2, as we can see. The name of the particle A. This particle A is a neutron. The proton number of particle B. So in particle B, we can see that 2 protons are present. So the proton number of particle B would be 2. The nucleon number, mass number of particle B. So in particle B, we have 2 protons, 2 neutrons, so the mass number is 4. At very high temperature, a very high temperature is needed to force nuclei together. Explain why. Okay, so the reason could be stated as the nuclei which are to be fused, they repel each other and very large kinetic energy is needed to overcome this repulsion. That is why we need very high temperatures for nuclear fusion reactions. The next part says a star forms from a large cloud of gas and dust in space. Describe what happens as the star forms. Gas and dust comes together because of gravitational attraction. Temperature rises and kinetic energy of gas and dust particles increase. Nuclear fusions occur at this very high temperature, and an equilibrium is established between the gravitational attraction, which pulls the particle inward, and the radiation or the pressure uh, outward generated by the fusion. So this is how the stars are formed. The isotope of hydrogen 3,1 has a half-life of 12 years. State what is meant by half-life. The time for number of radioactive nuclei to half is called half-life. So it is the time in which the radioactive nuclei they decrease by half. A sample contains 16,000 atoms of hydrogen 3,1. Calculate the number of atoms present in the sample after 12 years. So we know that we have a half-life of for this isotope of 12 years, and now we are being given a period of 48 years. So the number of half-lives in 48 years are going to be 4, which means that number of atoms could be found if we divide the initial number by 2 raised to n or 2 raised to 4, which gives us an answer of 1000 atoms. So the number of present quantity of atoms would be 1000 atoms. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.